Public speaking anxiety is very common, affecting approximately 1 in every 5 individuals. Given the importance of public speaking in the sciences, we explored how a mobile humanoid robot can help a human presenter in delivering an oral scientific presentation. Specifically, we investigate the effects of co-presenting with a robot on speaker anxiety and self-confidence. Our study builds on the literature on public speaking anxiety, presentation support systems, robot performance and coaches, and leverages findings from social impact theory. Public speaking anxiety, which can be either a trait or a state, is one of the key causes of poor oral presentations. Several presentation support systems in the literature address this issue either before, during, or after the presentations. The prior approaches span a wide range of applications from offering the speaker convenient ways to organize their slides and take advantage of speaker notes, to sensing-based systems giving haptic or visual feedback to the speakers based on their speech quality, or to virtual counselors conducting cognitive behavioral therapy sessions before presentations. Along with virtual agents and computer software, robots have also been used in similar domains as performance in stage performances, in delivering presentations in lectures, and as presentation critiques. The research in this domain demonstrates the potential impact of robots on presentation quality and audience experience. With our work, we extend this body of literature by evaluating the impact of a co-presenter robot that shares the spotlight with a human presenter. Based on the implications of social impact theory, it is known that a human co-presenter can help mitigate performance anxiety. Extending this, we investigate whether a robot co-presenter will have the same effect. To the end of evaluating a robotic co-presenter's effect on a speaker's presentation experience and on overall presentation quality, we conducted a two-stage user study. In stage 1, we recruited participants and asked them to deliver 2 scientific presentations in 2 experiment sessions on different days. In this within-participant study, participants delivered one of the presentations on their own and the other one with the robot. In the robot condition, the robot was controlled by the experimenter in a wizard-of-all setup. Participants were provided with a prepared slide deck and notes and were given time to practice the deck and rehearse their presentations. After the rehearsal, participants delivered their presentation while being watched and video recorded by the experimenter. In stage 2, the video recordings of the presentations were assessed in an audience perception study. Judges were recruited through Amazon Mechanical Turk to watch and rate the presentations and the presenters. In this study, we hypothesized that co-presenting with a robot reduces public speaking anxiety and improves the presenter's self-perceived presentation quality, and audiences would accept a robot as a co-presenter in scientific presentations. To evaluate the participants' confidence and anxiety levels in different time windows through the experiment, we utilized several measures. These measures were a single-item state anxiety measure, state trait inventory for cognitive and somatic anxiety, self-perceived communication competence scale, personal report of confidence as a speaker, presentation self-rating, and robot rating. Following informed consent and briefing, participants filled out questionnaires including social demographics, anxiety, communication competence, and confidence measures. Upon completing these baseline measures, participants were given 30 minutes to study the slide deck and rehearse their presentations. The anxiety measures were then collected a second time following the rehearsal period just before the recording session. After the recording session was concluded, the anxiety measures were collected a third time along with the speaker confidence measure, presentation self-ratings, and robot rating questionnaires. An exit interview was then conducted and participants were debriefed to finalize their sessions. In order to replicate a real-life public speaking experience in the lab environment, we created an artificial stage. The stage included a display screen and 2 spotlights. The first spotlight marked the main stage area so as to make sure the participants were always in the recording frame. And the second spotlight was used to illuminate the presenters and allowed the rest of the room to be dark, giving the feeling of being on an actual stage. In the robot condition, the participant and the robot took turns delivering presentation slides. When it was the robot's turn to present, it would thank the participant, roll onto the stage, and start delivering the current slide displayed on the screen. Once the robot was done presenting, it would look at its resting position and roll towards it out of the stage area and let the participant deliver the next slide. We recruited 23 individuals to take part in this 2-session study and 44 of the 46 planned experiment sessions were completed successfully. The data from the surveys were later analyzed using paired sample t-test, analysis of covariance, and one sample Wilcoxon signed rank test. The paired samples t-test analysis indicated significant effects of the robot condition on post-presentation anxiety measures as well as the speaker confidence measure. Note that the lower values in these box plots indicates lower levels of anxiety for STIXA and SA and higher speaker confidence for the PRCS measure. In the pre-rehearsal time window, the measures did not indicate any significant differences. In the post-rehearsal time window, only the STIXA scores have shown a trending difference between the robot and the control conditions. And in the post-presentation time window, all three measures indicated significant positive effect of co-presenting with the robot on speaker anxiety and confidence. We did not observe any significant differences in the presentation self-rating scores between the robot and the control conditions. Thus, we checked for single-item differences using one sample Wilcoxon signed rank test and found that the nervousness ratings were significantly lower in the robot condition. We furthered our analysis by taking the robot condition and the time window factors as within participant variables, and the treatment order as a covariate, and ran analysis of covariance. The ANCOVA on STIXA indicated a significant mean effect of the robot condition on anxiety measures in favor of the robot. Further, this analysis also revealed interaction effects between the robot condition, treatment order, and time window. In summary, these interactions indicated lower anxiety levels when the participants presented with the robot in their second sessions and lower anxiety levels after the presentation was completed under the robot condition. Similar effects were revealed based on the single-item state anxiety measures, where the participants have shown lowest anxiety levels after they presented with the robot in their second sessions. The personal report of confidence as a speaker scores followed a pattern in agreement with the state anxiety measures. Participants felt significantly more confident under the robot condition and felt a trending positive effect of presenting with the robot in their second sessions based on the post-presentation questionnaires. The effects found in ANCOVA indicated a possible learning effect, where the anxiety levels were lower and confidence was higher for the participants at the end of each session and also in their second sessions. However, the analysis also demonstrates that these positive changes were most significant under the robot condition, which agrees with the findings from the paired sample t-test analysis. For the audience perception study, we recruited 210 judges from Amazon Mechanical Turk. Each pair of presentations by one participant, with and without the robot, was watched and rated by a total of 10 judges. In this stage of the analysis, we did not find any significant effects of the robot on the presentation and the presenter performances. However, single-item results on satisfaction and credibility were trending such that audiences were more satisfied with the presentations with the robot, and they found these presentations less credible than the control condition. Overall, the presentations and the presenters with the robot were rated significantly higher than the neutral score. Our findings from this study demonstrated significant positive effects of a robot co-presenter on speaker anxiety and confidence, which is in line with the predictions of social impact theory for human co-presenters. Moreover, with the audience perception study, we have shown that audiences accepted scientific presentations delivered using a co-presenter robot. Further, during the interviews, we have noted participant comments along the lines of the robot co-presenter giving them a moment to breathe and helping them stop the avalanche effect to get in control of their presentations and having a chance to observe the audience's attention. We believe this application is a rare example of exploring the paradigm of human-robot collaboration in high-stress situations, where a robot is used as a calming technology. We thank you very much for your attention and kindly invite you to read our paper for more details about our study.